Okay.
Yeah, just a little bit.
That better?
Yeah.
Okay, learning target 5.2. If you were good at factoring last chapter, this learning target's not going to be something that's really, really difficult for you. If you struggle a little with factoring, we'll just have to make you better at it. We'll give you enough practice, hopefully. Okay? We're going to be factoring polynomials completely. Last chapter, it was all quadratic stuff, x squareds. Now we're going to move up. We're going to get higher powers of variables to be having to factor. Okay? Some of them get a little bit tricky, but for the most part, it's kind of the same idea. Greatest common factor first. See what's left over. Do you have a difference of two squares that you could use? Do you got to use the special factoring trick that we worked on? Lots of different ways you can do it. You just got to do a lot of them to the point to where you feel pretty comfortable with it. Okay. I'm just going to do some examples with you and kind of talk my thought process with you. Okay, you can kind of see what I'm doing. So the directions simply, for the most part, are going to be, okay, just factor. You don't even have to solve, for the most part. Okay. Let's say I had 30 b to the third minus 54 b to the second. Okay. And again, I would do these problems with me. I might write down any pieces of advice that I might give you when it comes to factoring, just so you can kind of refer back to it. Because again, without doing it, factoring can be difficult. But once you do it, it's really not that bad. Okay? Anytime you factor, the first thing you always want to look for is there a greatest common factor? Is there something that every term is divisible by that you can divide out of each term? Because that can make what's left over really simple to work with. Okay? So when I see this, I think, okay, I got two terms here. Is there anything that go into both terms evenly?
6.
6. Anything else?
3.
3. I agree. We want the highest number possible. So if it was 6 and 3, we go with 6 as far as what we're going to pull out. Okay. Absolutely. So we got. Can it go higher than 6? Is 6 the biggest number that goes into both terms?
9. No, never mind.
Nope, 9 won't go into that one either. It would have gone into this one, but not this one. So 6 is definitely our biggest number. Anything else?
B squared.
B squared? Does b squared go into each term? Does each term at least have a b squared in it?
Yeah.
Yeah, this one's got BBB. This one's got BB. They both got BB at least. Okay, so b squared is also a part of the greatest common factor. So I can take out a 6b squared out in front. I can pull that 6b squared or divide that 6b squared out of each term. And then what would be left over out of each term then if I took a 6 and a b squared out of this term?
5b and 9.
5b minus 9. Yep. So now I have two factors. 6b squared is a factor, and this whole quantity right here, 5b minus 9, that's a factor. They are both factors of this, because what would happen if I took this factor times this factor? Get right back to where you started, right? And that's the whole idea with factoring, just like when you made your factor trees, right? Okay. How do you know you're done? Well, look at this factor that's left in the parentheses. Could that be factored any further? No, it can't. As soon as you get down to a linear factor, what do I mean by a linear factor? Not two terms.
There's no exponents?
What's that?
There's no exponents.
There's no exponents. Linear, y equals mx plus b. Do I have any exponents on that x? Y equals mx plus b. It's just x to the first power, right? So it's a line. If you were to graph this, y equals 5x minus 9, wouldn't that be a line with a slope of 5? As soon as you get it down to a linear term, there is no way that you could factor it any further, as long as both numbers are not divisible by the same thing. Okay? So here's one mistake that I could see happen. All right? Maybe you just thought 3 was the biggest number that went into both terms. And so let's say you only pulled a 3b squared out of both of them. 3b squared, and then you'd have 10b minus 18 left over. Okay? This still works, right? If I take this times this, don't I get back to where I started? You guys staying with me here?
Yeah.
But look at your factor in here, 10b minus 18. They're both divisible by 2, so we also could have pulled another 2 out, which would give us our 6 out there. So I guess after you pull out your greatest common factor, if you see, oh shoot, I could have pulled a bigger number out, all right, then you know you didn't pull out the greatest common factor. You pulled out a common factor, just not the greatest common factor. Okay? That okay?
Yeah.
All right, let's do another one. When I get up to about 11 or 12 minutes, guys, just let me know.
It's 6.
All right. X to the third minus 6x squared minus 72x. Factoring is awesome. I love factoring. So it wasn't. Just figure out what multiplies.
Nerd.
Alright, so again, first step, always think, what's my greatest common factor? What can I take out of everything?
3.
Nope,
X.
Oh, only X.
3 doesn't go into that.
I just made it.
No, that's alright, 3 would have gone into those two, but it's got to go into all 3 terms.
Only X.
So is X our greatest common factor here?
Yeah.
Okay, so I take out an X. What's left over?
X squared.
X squared
Minus 6X.
minus 6X
Minus 72.
minus 72.
And we're done.
You think you're done?
I think so.
He thinks he is, but no. He wrong.
But do I have a linear term left over?
No.
I have a quadratic term. Sometimes our quadratic term's factorable. Did you ever have to factor something like this last chapter?
Yeah.
Only if there's numbers that multiply to this and add to this. Is there?
So it's negative 12.
Yeah, nice. Negative 12 and 6.
He does.
Yep.
Good job.
So I still got my x out in front, but now you think, what times what gives me x squared? X and x. And then what two numbers multiply to a negative 72 and add to a negative 6?
Negative 12.
Negative 12 with a positive 6, so it doesn't matter which one you write where. So x minus 12, x plus 6. If you weren't quite sure, what could you do to make sure you were right? Foil it back out, okay, multiply it back out to make sure it equals what you started with. Now do I have all linear terms?
Yes.
Yep, that's a linear term, that's a linear term, that's a linear term. Alright?
X.
On a roll. Greatest common factor, 8x. Okay? So I take out the 8x. What's left over?
X squared and minus 9.
X squared minus 9. Done?
But you can't factor that out.
You can or you cannot.
Can't.
You probably can't, from what we've been taught,
But you're gonna give us a
you
new
probably can
knowledge,
come
aren't
up
you?
with some little.
What do you think, Casey? Have confidence.
You probably can.
Maybe you take out the x and 3. Like x and 3, because
So what do you got?
Ax exponent x plus 3 and then x and x minus
X plus 3, x minus 3?
isn't that what I said?
Difference of two squares.
It's pretty much what I said. I mean, I said that. And then he took
Do you
it.
remember the difference of two squares rule? A squared minus b squared factors to a plus b, a minus b.
Yeah,
Okay? And you have been taught that already.
yes we have. Alright, I was wrong.
That's all right.
He's tricky.
Yeah.
He tries to
11 minutes.
mess.
This is the difference of two squares. You know, if you had x squared minus 25, it would be x plus 5, x minus 5. If it was x squared minus 100, x plus 10, x minus 10. It only works when it's a difference of two perfect squares. If that was x squared plus 9, we would have been done right here. If that was x squared plus 9, you would have been done. You cannot factor the sum of two squares any further. The difference of two squares you can definitely factor further. It becomes x plus 3, x minus 3.
11 and a half.
Sorry.
Okay?
Almost 12.